operations here means addition, subtraction, multiplication. You see, one radical times another quantity with radical involved, and division. Okay, division. Yeah. So operations with radicals. Before we do that, we want to review distributive property. Look, 2 times bracket 3 plus 4 close bracket. We know 3 plus 4 should be added together, which is 7 first. And then 2 times 7 is 14. And then, 2 times 3 is 6, 2 times 4 is 8. Add together, 6 and 8 is also 14. So basically, it tells us here 2 times bracket 3 plus 4 close bracket is 2 times 3 plus 2 times 4. So in general, we have A times quantity B plus C equals A times B and A times C. Okay? That's the distributive property. One thing we want to review first. Another thing is that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. By definition, radical 1 is 1, radical 4 is 2, radical 9 is 3 here, and radical 16 goes back to 4. Okay? We also know 1 squared is 1. So you can write radical 1 squared is 1. 4 is 2 squared. So you can write radical 2 squared is 2. Because you can also write 2 as our index. But in general, if it's 2 as our index, then we don't need to write. Okay? 9 is 3 squared, so radical 3 squared is 3. 16 is 4 squared, so radical 4 squared is 4. In general, we have a radical x squared is x if x is greater than or equal to 0. And similarly, we have a cube root of x cubed is x. Now, we know 4 times 9 inside the radical sign, 4 times 9 gives us 36. 36 is actually 6 squared, and radical 6 squared is 6 because, the general formula right here. Okay? Radical x squared is x. It's like radical 4 squared is 4. So we have a radical 6 squared is 6. Now, radical 4 times radical 9, we know radical 4 is 2. You see here. Because 2 squared is 4, so definition tells us radical 4 will give us 2. So radical 4 is 2, and radical 9 is 3. 2 times 3 is 6. 6 are equal. Actually, it tells us right here is radical 4 times 9 equals radical 4 times radical 9. They are equal. So in general, we have a radical AB equals radical A times radical B. And if A and B are equal, like, for example, A is 3, B is 3, then by this formula, you have a radical 3 times 3 is radical 3 times radical 3. We know radical 3 times 3 is 3 squared, and radical 3 squared is 3. You see, radical 3 squared is 3. This tells us radical 3 times radical 3 is 3. Okay? Now, similarly to multiplication, we have a division here, is that radical A over B equals radical A times radical B. Okay? With distributive property in our mind, with those two properties and with those two properties, we should be able, we are ready to do the multiplication first. You know, 12 radical 2 plus 3 radical 2 is like 12 plus 3 times radical 2 is by distributive property. Okay? So it looks like you have a radical 2 times 3, radical 2 times 12. You see it goes back. Okay? And so 12 plus 3 is 15. You leave radical 2. And that's the final answer. Now try this one yourself. Again, you take radical 3 out. It's actually 15 minus 2. That's 13. 13 times radical 3. That's the final answer. Try this one yourself. Actually, I did it for you already. Now, radical 80a plus radical 125a. We know 80 is 16 times 5, and 16 is 4 squared. So the first term, radical 80a, is 4 squared, radical 4 squared times 5a. Similarly, the second one, radical 125a, 125 is 25 times 5. 25 is 5 squared. So you have a 5 squared times 5 is 125. And then you leave a inside the radical sign. The reason I'm doing this is because radical 4 squared is 4. So we have a radical 4 squared here, so 4 can be out. And then you leave 5a inside. Here, 5 squared is inside the radical sign, so similar reason, 5 can be out. Have a radical 5a. Okay? And then 4 plus 5 is 9. You leave radical 5a. Try radical 98a minus radical 32a yourself. You know, again, 98 can be written as 49 times 2, and 49 is 7 squared. 32 can be written as 16 times 2, and 16 is 4 squared. So 7 minus 4 gives us 3. 2 stays inside, that's 2a. 2 stays inside, that's 2a. So 2a, you leave it. So the final thing is 7 out, 4 out. 7 minus 4 is 3. And you have a radical 2a. Try this one yourself. Make up all the middle steps. Now, let's look at this one. This one is cube root of r to the 5th minus cube root of 8r to the 5th minus r times cube root of 64r squared. R to the 5th can be written as r cubed times r squared. The reason I'm doing so again is because cube root inside cube root we have a r cubed. So based on the rhythm right here, we have a cube root of x cubed is x. X can be out. And that's why I'm doing that. Now r is out, and inside you have a cube root of r squared, so you leave it. Now, 8 is 2 cubed. Again, r to the 5th can be written as r cubed times r squared. So 2 cubed, r cubed can be out. You have a 2r. And here r squared stays inside cube root. Okay. Last one is this term. 64 is 4 cubed. So cube root of 4 cubed, 4 can be out. There is r outside, so we have a 4r. Inside, r squared, still inside. Now we have a 3 cube root of r squared, cube root of r squared, cube root of r squared. And you have a r. The only thing is here you can write 1. 1 times anything is that thing. Here is -2, here is -4. Together, 1, -2, -4 is -5. You have r, you leave it. You have a cube root of r squared, you leave it. So that's the final answer. Try this one yourself. This one is cube root of 3a minus cube root of 24a plus cube root of 375a. 24 is 8 times 3. 8 is 2 cubed. 375 is 125 times 3. 125 is 5 cubed. So, cube root of something, you have a 2 cubed. Cube root of something, you have a 5 cubed. So, you have a 2 is out, 5 is out, and you have a 1 here. In front of 2, you have a negative. So, it's 5, -2, 1, which gives you 4. And you leave 3a, 3a, 3a inside the cube root sign. And this is the final answer. Try this one yourself. Now let's look at this example. Cube root of 2 times cube root of 4 plus 3. Again, you want to apply the distributive property right here. So you have a cube root of 2 times cube root of 4 plus cube root of 2 times 3. And 4 is 2 squared. 2 squared times 2, you have 2 cubed. But outside, you see, is still cube root. Okay? So 2, 4 is 8. But 8 is 2 cubed. Now, plus cube root of 2 times 3 is actually 3 times cube root of 2. 3 times cube root of 2. This one is cube root of 2 cubed, so it's 2. Okay? So the final answer is 2 plus 3 cubed. 2 plus 3 times cube root of 2. That's the final answer. Try this one yourself. That's cube root of 3 times cube root of 9 plus 2. Again, cube root of 3 times cube root of 9. 9 is 3 squared. 3 squared times 3 gives you 3 cubed. And then cube root of 3 cubed is 3. And 2 times cube root of 3, you leave it. And this is the final answer. Now, try this one. Let's look at that. This one we need to use for your method. 2 square root 3 minus 5 radical 2 times quantity 3 radical 3 plus 2 radical 2. The first product is 2 radical 3 times 3 radical 3. 2 radical 3, 3 radical 3. outer product is 3 radical 3 times 2 radical 2. 2 radical 2, 3 radical 3. Inner product is negative radical 5 radical 2, 3 radical 3, 5 radical 2, 3 radical 3. The last product is negative times positive. You have a negative 5 radical 2 times 2 radical 2. 5 radical 2, 2 radical 2. So that's the FOIL method. Now we know 2 times 3 is 6. Radical 3 times radical 3 is 3. See, radical 3 times radical 3 is 3. Now, 2 times 2 is 4. Radical 3 times radical 2 is 6, because 3 times 2 is 6. Okay? Now, 5 times 3 is 15. You have a negative here. Again, radical 2 times radical 3 is radical 6. Okay? That's the property. We have it right here. Radical A times radical B is radical AB. If here is 2, here is 3, then 2 times 3 is 6 inside the radical sign. So that's why we have a radical 6 here. Okay? Now, 5 times 2 is 10. Radical 2 times radical 2 is 2. It's like radical 3 times radical 3 is 3 here. Radical 3 times radical 3 is 3 here. All right. 3 times 6, 6 times 3 is positive 18. 10 times 2 is 20, but here is negative. So 18 positive, 20 negative. Together we have a negative 2. Negative 15, positive 4. Together we have a negative 11. And then we leave radical 6. Try this one yourself. That's 7 radical 5 minus 11 radical 7 times bracket 5 times radical 5 plus 8 times radical 7. Again, you need to use FOIL method, and eventually you will have a final answer, which is negative 441 plus radical 35. Okay, let's look at this one. This one is bracket 2 plus 3 radical 3 times 2 minus 3 radical 3. You can see here is a little bit special. 2, 2 are equal, 3 radical 3, 3 radical 3. The only difference is negative, positive, positive, negative. For this special case, you will see the special result. Again, use FOIL method. 2 times 2 is 2 squared. That's the first product. An outer product is 2 times negative 3 radical 3. 2 times 3 radical 3 negative. Inner product is 3 radical 3 times 2. 3 radical 3 times 2. The last product, you have a positive, negative, so it will have a negative. 3 radical 3 times 3 radical 3. You have it right here. If you look at those two middle terms, 2, 3 radical 3, 3, 2 radical 3, negative, positive will cancel each other. So for this special case, positive, negative, you always got middle two terms are cancelled. And then you have a 2 times 2, which is 2 squared. You have a 4. 3 times 3 is 9. Radical 3 times radical 3 is 3. 3 times 9 is 27. And 4 minus 27 is negative 23. Okay? Try this one yourself. Again, you will have two middle terms will cancel each other, because 2 equals 2, Radical 3 equals radical 3. The only difference is plus minus. Plus minus. When you apply the Fourier method to that, you will get two middle terms cancel each other. So you have a 2 times 2 is your first term, which is 4. The last term is radical 3 times radical 3, which is 3. Positive, negative gives you negative. So it's actually 4 minus 3, which is 1. Try this one yourself. Now, let's look at rationalize the denominators. This is 3 plus radical 3 over radical 2. We know we don't like denominator as a radical number. So we want this one to be integer. That is called rationalize the denominator. We know radical 2 times radical 2 will give us 2. So we need to use both numerator and denominator multiplied by radical 2. Okay, because you cancel radical 2, you got radical 2 upstairs, radical 2 downstairs. This is just 1, alright? Okay, so radical 2 times radical 2 is 2. 3 times radical 2 is 3 radical 2. Radical 3 times radical 2 is radical 6. And you are done, because denominator now is 2. Try this one yourself. 2 plus radical 5 over radical 3. Again, you need to use radical 3 upstairs, radical 3 downstairs to multiply this rational number, this fraction. Radical 3 times radical 3, you have a 3. 2 times radical 3 is 2 radical 3. Radical 5 times radical 3, you have a radical 15. And this is the final answer. Now, let's look at the last example. The last example says that 4a over 3 minus radical 5. How are we going to do that one? You see, if we have a 2 plus radical 3, then we have 2 minus radical 3. We have an integer. 2 plus 3 radical 3, 2 minus 3 radical 3, then we will have an integer. The final answers in those two, there is no radical numbers are involved. So, by the hint right here, we do is both numerator and denominator multiplied by a same number, 3 plus radical 5, 3 plus radical 5. The reason is that we know 3 minus radical 5 times 3 plus radical 5, you will get, when you apply the Fourier method to denominator, you have a 2 middle terms cancel each other. So you have a 3 times 3 gives you 3 squared. And then you have a radical 5 negative times positive radical 5. You have a negative radical 5 times radical 5 is 5. Okay? So 3 squared is 9. 5. So 9 minus 5 is 4. Upstairs is 4a times 3 plus radical 5. By distributive property, you see here, and you know 4 is downstairs, 4 is upstairs, you cancel 4, 4. Basically you have is that you only need to distribute a to 3, which is 3a, and a to radical 5, which is radical 5a. Try this one yourself. 3a over 4 minus radical 3. Again, right here, you want to multiply 4 plus radical 3, 4 plus radical 3 upstairs and downstairs. Okay? So you will have, here is like 9 squared, 3 squared, which is 9. Radical 5, radical 5, you got 5, 9 minus 5. So here you have a 4 plus minus 3 times 4 plus radical 3, 4 minus radical 3. You have a 4 squared, which gives you 16. Radical 3 times radical 3, which gives you 3. So 16 minus 3 gives you 13. Okay? Upstairs, 3a times 4 plus radical 3. So you have a 12a. And then 3a times positive radical 3. So you have a 3a radical 3. Try this one yourself. Okay? Please review this lecture. I'll see you next time.